Hello and welcome to Unit 7, Day 6. Today we're going to be discussing kites. Yes, the kite is a real shape in geometry. A kite is a quadrilateral, even though some of the ones we see flying in the sky are not. A geometrical kite is a quadrilateral, so it has four sides. Two pairs of opposite sides that are non-congruent. So that means these opposite sides are going to have two different lengths. They're not going to be the same like they are in a parallelogram. And two pairs of consecutive sides that are congruent. So that means a side that's right next to this one is going to equal it. The two that are right next to each other, that's what we mean by consecutive, one right after the other, are equal. And there's two pairs of those. So these two will be the same length and these two will be the same length. It's kind of like if you took a rhombus and then you took one corner of that rhombus. So if this was a rhombus and I took one corner and I just stretched it, right? That's what a kite is like. It's like stretching out one corner of a rhombus. Okay? There are three special properties that we need to make sure we have memorized for kites. The first one is one pair of opposite angles are congruent. And then it tells me that they are the side-to-side angles. When I measure, or when I label a triangle or a kite, I always think about its top and its tail, and then its sides. So a kite, if you think about flying this one, right, you're going to have a tail, which means the other end from that is going to be the top of that kite. So it's going to have a top and a tail, and then you're going to have the two sides. So a side here and a side here. Okay? So one pair of opposite angles, the side-to-side angles, will be congruent. So if I know how big this angle here is, then this angle here is exactly the same. Okay? But notice it only says 1. So that means these angles are not the same. They are going to be different. One of these will be bigger, the other one will be smaller. Okay? That's my first special property of my kite. The second special property of my kite is that my diagonals are perpendicular. And remember, sometimes you won't see that word written out, you'll just see the upside down T. And remember, that means they intersect at a 90-degree angle. So if I draw in my two diagonals, here and here, they are going to intersect at a 90-degree angle. Okay? All right. This last one kind of encompasses quite a bit, so let's make sure we look at it carefully. The top to tail diagonal bisects both the top and the tail angles and the other diagonal. So let's talk about what exactly that means. My top to tail diagonal. So here's my tail. Here's my top. This top to tail diagonal. It bisects the top and the tail angles. So whatever this is, it gets divided into two equal angles. Whatever this is, it gets divided into two equal angles. Now, notice I put different marks on them because it's not like a rhombus. I said my side-to-side angles are congruent, but my top and tail angles are different from each other. Okay? They are bisected. They're different from each other, but they are equal on either side of the diagonal. Now, that's not all it bisects. It also bisects the other diagonal. So when I draw in the other diagonal, this one gets bisected. Okay? So notice this one is not bisected. I'm going to have a short piece and a long piece, but my side-to-side diagonal does get bisected. So the side-to-side diagonal gets bisected, not the top-to-tail diagonal. It's opposite for the angles. My top and tail angles are bisected. My side-to-side angles are not bisected. These two angles here, they are not the same. One of these is always going to be a little smaller than the other one. These two angles here are not the same. Okay? They are going to be different from each other. They are not bisected. Okay? And I have that right here in small little print. The side angles are not bisected. the top to tail angle is not bisected. Okay? All right, so now that we have our properties, let's see what we can do with that. Okay? Example 1, in kite ABCD, so it's already telling me it's a kite. The measure of angle DAB is 54 degrees, and the measure of angle CDF is 52 degrees. Find each measure. Okay, so when I look at this, I know I'm going to have congruent sides here, congruent sides here. I'm going to have a top, I'm going to have a tail, and then I know I'm going to have 90 degrees here. I know this is going to be bisected into equal pieces. I'm using 3 tick marks because I've already used 1 and 2. Okay. I know these are going to be bisected, and I know these are going to be bisected, but these are not bisected. Okay. That, what I marked in there, is true for every single kite. So now let's look at the information they gave us. The measure of angle DAB. So DAB. That is that whole angle down there at the bottom. Okay, that whole angle is 54 degrees. So think about what each side would be if it's been bisected, right? I believe that's going to be, let's see, 54 divided by 2, is that 27? Is 27 degrees. So if this whole angle is 54 degrees, that means each angle here is 27 degrees and 27 degrees. These angles up here are not 27 and 27 because these angles on my top and my tail are different. Okay? Then the next thing it tells me is CDF is 52 degrees. So CDF, CDF, there's F is in the middle. It's hard to tell because I've been writing. So CDF is 52 degrees. That does not mean this angle is 52. These are different angles on my side to side. Okay, the side to side angles are not bisected. The top and the tail angles are bisected. Okay, so now it says to find each measure. Okay, so that's my task now. When I look at these two triangles, if I kind of like cover up part of this, let's see if I can do that this way. There we go. When I look at these two triangles, I can see that all 3 sides are the same. I've got 3 tick marks, 3 tick marks, a single tick mark, a single tick mark, and then I have this reflexively shared side. So by side, 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 these triangles are exactly the same. So however big this angle is, the matching angle would be the same. So those angles are both 52. Okay. Then I also know, because it's a kite, all the angles in here at the center are 90. 90. Okay. So then the only other angle I need are going to be these 2 angles up here. So again, if I go on there's a reason we spent so long on triangles, right? We use triangles for pretty much everything we do. If I then keep covering up and I look at just this little triangle here, I know the triangle has 180 degrees. I've used 90 here. I've used 52 here. So 90 plus 52 is 142. There's 180 degrees in the whole triangle. 180 minus 142 is 38 degrees. So that angle is 38 degrees, and this angle is 38 degrees. All right, so let's see. There's only 2 more angles to find, I believe. Well, 3 more if you count this one, but look, I already found it. Look, haha, it's 90. So now I just need to find this little angle here, and I need to find this little angle here. But we're going to be able to do that pretty simply because the same way we did the last one, I know that these triangles have to be the same. So if I can find one, the other is going to be exactly the same. And I'm going to do the same process that I did on the last one. I'm going to say, well, I have a triangle here where I've got 90 degrees and 27 degrees, and I want to know what's left for this corner. So 90 and 27, what's left for this corner? 90 plus 27 is 117. I'm going to take that away from 180. (63°). So this angle here is 63, and this angle here is 63. Okay? And kind of a neat way you can check to see if everything is correct. Your side angle should be the same. It's different on one than it is on the other, but they match the other side, 52 and 63. All four of your angles together should make 360 degrees, because a kite is a quadrilateral, and every quadrilateral has 360 degrees. So if I go around and I add all my angles together, 38 plus 38 plus 52 plus 63 plus 27 plus 27, although I could have just done 54, plus 63 plus 52, almost couldn't read my own handwriting, and I get 360 degrees all the way around that kite. Alright, let's move on with example 2. Erin is making a kite based on the pattern below. She wants to add trim around the border. How much trim does Erin need to cover the edges of the kite? Alright, so as I work through this one, the first thing I'm going to see is I'm going to look at my sides and try to figure out how long they are, because if I'm trying to put trim all the way around this figure, that's basically just asking me what is the perimeter of this kite, right? It's just a fancy way of asking me the perimeter of the kite. So let's say I wanted to start by finding out how long. I'm just doing it like this because it's trim on the kite, and I thought it'd be prettier if it was a little scalloped trim on my kite. If I want to know how long that piece there is, okay, I can use the fact that I know my diagonals intersect at a 90-degree angle. Okay, I know one side is 52, and I know that this top to tail diagonal, that's my tail, this is the top, I know the top to tail diagonal bisects the side to side diagonal, so I know those two pieces are equal. If the whole diagonal is 64, that means each one of these little sides is 32, so that 32 and 32 makes the whole length 64. So now I have enough to use Pythagorean theorem to find the hypotenuse of this triangle. Okay, so that's what I'm going to do. If I'm trying to find the hypotenuse, I'm going to add in my square root. My two numbers are 52 and 32. I put the bigger one in first always. And that's going to be 52 squared is 2,704. Oops, 704. And 32 squared is 1,024. So that's going to be the square root of 2,704 plus 1,024 is going to be 3,728, which is about, I'm going to round to 3 decimal places. The square root of 3,728 is about 61.057 if I round correctly, and these are inches. And it's not area like it was in the last lesson, so I don't have to put that square on there. It's just plain old inches. So this one here is 61.057. What's nice is that means I've already done the work for this one, 61.057. Okay? All right, now let's find the trim for these two sides. I'm going to do one at a time. I'm going to do this one, which I know is going to be the same as that one. Same exact process. I know this side here is 13. I know I have a 90-degree angle here, and I know this piece here is 32. I'm looking for the hypotenuse. So inside my square root, when I'm looking for a hypotenuse, I know I'm going to add. 32 and 13, I always put the bigger number in first. 32 squared and 13 squared. I already did 32 squared. It was 1,024. And then 13 squared, 13 times 13 is 169. And then I add those two together. And I get 1,193. And when I square root that, I get 34.5398. So that's actually going to become 40. 34.540 for both of these. Okay. All right. So then what I need to do, it says how much trim do we need to cover the edges of the kite? We need to add all four of them together, and we need to find the perimeter to find how much trim she needs. So it's going to be the 61.057 plus the 61.057 plus the 34.504 plus the 34.504. Or sorry, 540. That's going to tell me how much trim I need. 61.057 plus 61.057 plus 34.540 plus 34.540. If I hit all the buttons right, we should be 248.137 inches. Okay. Now let's say she goes to Hobby Lobby or wherever she goes, and they're like, oh, you have to buy it by the yard or by the foot. Okay. So let's say she's buying it by the foot. What would I still need to do to this? I'd have to then divide this by 12, right? So if I divide that by 12, I need 20.6781 feet. Now, when I go to Hobby Lobby, they're not going to let me buy 0.6781 of a foot, right? So I'll probably have to buy that whole other foot or figure out how many other inches that's going to need to be. Okay. So that's how much total trim in inches she's going to need, but be careful. Sometimes they're going to ask you for the answer potentially in different units. So make sure you're paying attention, especially on a word problem like this. Okay? Let's look at example 3. Find each angle measure in the figure below. When I'm doing these problems, I really like these kind of problems. These make me, it's like doing like a Sudoku or a puzzle or something. They're super fun for me. Instead of going, okay, E, F, G, let me find that over here, and then figuring out what it is, I just like to blanket go and say, I'm just going to figure out what all those angles are and be done with it. Okay? Like I already know this is my tail, and this is my top, and if you get those two backwards, it's okay. You're just flying upside down. It's okay. The important thing is that the two that come together where they're different that come together, those have to be your sides, right? So side and side. Okay. My first property says that my opposite angles that are side to side are congruent. So my side to side angles have to be equal. So if this one's 113, then the other one's also going to be 113. I'm going to do these. My side-to-side angles are equal. Okay? Then I go, well, hold on. This is a quadrilateral, which means all four of those angles, they have to add up to 360 because it's a quadrilateral. So it still has all those quadrilateral properties. So the four angles in a quadrilateral, because it's really two triangles that are next to each other, they have to add up to 360 because 180 and 180. So I'm going to add the three angles I already know, 113, 113, and 44. So that's 6, 10, 4, 5, 6, 7, 270, and I know I'm a total of 360. So 360 minus 270, I believe, is 90. Is 90. So that means this angle here is a right angle. That's fun. I'm just going to put the right angle box there. Okay. All right, 90 degrees. I'm going to write it in there too for fun. So that way if you're looking at it and not watching the video, maybe you'll know we found it and didn't just already have that there. Okay, so now I'm going to need to find the angles that are created when I draw in the diagonals. So I know, first of all, when I draw in my top to tail diagonal, my top to tail diagonal is going to bisect the top and tail angles. So when I draw this one in, it's going to divide this one into 22 and 22, and it's going to divide this one into 45 and 45. When I draw this one, it's real tempting to say, okay, it's going to divide this in whatever 113 is divided in half, so 56.5, 56.5, 56.5. But remember, your side-to-side angles are not bisected. Okay, so you have to figure out what those are. But I do know that my diagonals are perpendicular, so all these angles in here are 90. Okay, so now I know something cool. I immediately go, oh, if I have 45 degrees and 90 degrees, this must be a 45, 45, 90. 45, 45, 90. So now all I need to do is figure out what this is, and I have two ways to do that. I can either subtract the 45 from 113. If I subtract 113 minus 45, that gives me 68. So this angle over here would also be 68. Or the other thing I could do is I could take away the 90 and the 22 from 180, right? Because I can think of this as a little triangle here, because it is a little triangle here. So I could do 90 plus 22, which is 112, and I could say 180 minus 112, which is also 68. So it doesn't matter which method you use, you're going to get the 68 there. Okay, so now we found all our angles. This part's going to be so easy now, because all we have to do is find the, it's like an Easter egg hunt now, we just have to find them. So the first thing I'm going to look for is EFG. So F is up here. F was in the middle on that one over there. And then where's G? G is over here. EFG, that orange angle is 90 degrees. All right, found the first Easter egg. The next one, FGH. FGH. Well, that one I didn't really even have to find because they gave me that one, right? I already know that's, oh, well, I didn't because they gave me this 113. I had to find this 113 degrees. All right, my next Easter egg is EHF. EHF. This pink angle is 22 degrees. Then GFH. GFH. This angle here is 45 degrees. FEG. FEG. FEG is 45 degrees. And last but not least, my last little egg that I need to find is EGH. EGH is 68 degrees. We are going to be looking at finding the area of kites. Okay? One of the great things about kites is since the top to tail diagonal bisects the angles at the top and the tail and bisects the side to side diagonal, and then I have congruent angles here and here, not bisected but congruent, I really do have two congruent triangles. The top, or the one side, I guess we should call it, of the kite is exactly the same as the other side of the kite. So to find the area, if I can find the area of one triangle, all I have to do then is double it. So it's going to be 2 times this one side, which is a triangle. Okay, so let's find the area of the top triangle. The area for the top triangle is going to be 1/2 its base times its height. So let's look at how long that base is. It's going to be the 13 and the 52 together. So I'm going to do 13 plus 52. That base is 65. The height, what's nice is the height can be found using half of this other diagonal, because I know in a kite those diagonals intersect at a 90-degree angle. If the whole side-to-side diagonal is 64, I know the top to tail diagonal divides that in half, so this is 32. So my area is 1/2 of 65 times 32. 1/2 times 65 times 32 is 1,040. Okay, so the area of just the top part is 1,040, and it's inches squared because it's area. My total area then is going to be 1,040 for the top and 1,040 for the bottom. So it's 2 times that 1,040 square inches. So that is going to have an area of 2,080 square inches. Okay, let's look at my second example. On my second example, again, I'm going to do the same thing. I'm going to look at just the top triangle, and then I know I'm going to double it, and that's going to give me my whole area. Okay, so just the top triangle is going to be area equals 1/2 the base times the height. My base, all the way across the bottom here of this triangle, is one of my diagonals. It's my top to tail diagonal, 20. And then the other one is going to be half of my side to side diagonal, which is going to be 8. So the area for this one is 1/2 of 20 times 8. 1/2 of 20 is 10. 10 times 8 is 80. And I don't know what the units are here, so I'm just going to say units squared. Remember, don't ever put that square on the 80. It goes on the units. So then my total area, I have 80 for the top and 80 for the bottom, so it's going to be 2 times the triangle. So my area is going to be 2 times the 80 units. So my area is going to be 160 square units. Again, that square cannot go on the 160. It has to go on the units. Okay? All right. When I look at the next one, here we go, I am going to have to draw in that triangle, right? Because I don't see it there, right? I need to draw in the top triangle so I can see it there. And I'm also going to draw in its height, because I know the area is going to be 2 triangles. So I need to figure out how big one of those triangles is. So the triangle equals 1/2 its base times its height. So that's going to be, the base is my top to tail diagonal, which is 38. And the height is half of the side to side diagonal, so half of 19 is going to be 9.5. It's okay to have decimals. So 1/2 times 38 times 9.5, 19 times 9.5 is 180.5. I'm going to do that one more time just to make sure I didn't get any buttons pushed wrong. 1/2 of 38 times 9.5. 180.5 is the area for the top triangle. So then my total area is going to be 2 of those triangles. What are these? They don't have any units, so it's just square units. So my total area then, when I multiply 180.5 times 2, it's going to be 361 square units. Okay, so a nice simple way using triangles to find the area of a kite. Okay? There is, if you look at a formula chart, a formula for the area of a kite. My formula for the area of a kite is the same as the formula for the area of a rhombus. 1/2 diagonal 1 times diagonal 2. And let's think about why that is. Each time when I came up here, I had to do half of this diagonal to be my height, right? So I already did half a diagonal, so it's like 1/4, right? Half of a half is 1/4. And then I multiplied that by 2, so I doubled my 1/4, so I was right back at my half and then my 2 diagonals. So it kind of is interesting how that kind of works together, and it just kind of shortens it so you don't have to do it in 2 separate steps. So that's really all the formula is doing. It's shortening it so you don't have to do it in 2 separate steps. 1/2 diagonal 1 times diagonal 2. So let's see if we can use that formula for these problems. Okay, so the first one, area equals 1/2 diagonal 1 times diagonal 2. So diagonal 1, it doesn't matter which one, just like with my rhombus, it doesn't matter which one we call diagonal 1 or diagonal 2. If this is my diagonal 1, then it is 2 plus 10, it's 12. Diagonal 2 is 6 plus 6, it's also 12. 12 times 12 is 144, which would be 72. Or half of 12 is 6, and 6 times 12 is 72. You can do it either way. I don't have any units here, but I can't put the square on the 2, so I have to write units squared. I could just put a U if I'd like. Okay, let's do one more, and we'll leave the last 2 for the next video. Okay, all right, so when I look at this one, my area equals 1/2 diagonal 1 times diagonal 2. I'm just going to use this one as diagonal 1 because it doesn't really matter which one's 1 and which one's 2. So on this one I have to go 12, and then I have to go another 8, so that's a total of 20. Hold on, we're getting an announcement.
Teachers, please excuse this interruption. Would you please check your email? Please check your email. Thank you.
I will be finishing this problem and checking my email. Alright, so then I want to find this diagonal here. For this diagonal, I know if I can find one piece of it, the other piece is going to match. So what I'm going to do to find the one piece is I'm going to use the idea that I have right triangles that make up my kite. Where I know my hypotenuse is 12 or 13, one of my legs is 12, and I'm looking for the other leg. So to find this other leg, since it's a leg, in my square root I'm going to subtract 13 and 12, the bigger number goes in first. So that's going to be 13 squared is 169, 144. That's going to be 25. So that is 5. It comes out to a nice whole number. I love it. So those are both 5. So this is 5 plus another 5. That diagonal is 10. My total area then is 1/2 of 20 times 10. Half of 20 is 10. 10 times 10 is 100. Or I could do 20 times 10 and get 200. Half of that is 100. Or even half of 10 is 5, and 5 times 20 is also 100. Doesn't matter the order you multiply those in. So here I'm going to have my area is 100, and I don't have any units written there, so I can just do a unit squared, or I can write out the word unit squared. But whatever you do, don't put the square right on the 100. It has to go on the word units or the U. So let's look at these last 2 problems. A company is designing a logo for 3 congruent kites to be embroidered on their staff polo. What is the total area of the logo? Okay, this is important because some places when you're doing embroidery work, they will charge you by the amount of area of yarn or thread that they're having to use to make up that portion of the logo. Okay, so it's important to know how much yarn or space you're going to be using up, or thread. So the first thing I need to do is notice that I've got 3 congruent kites. So really I'm just going to have to find one kite, and then once I know one kite, I can multiply that answer by 3. So the first thing I'm going to do is find the area of just one kite. So I know it's going to be 1/2 its diagonal times its other diagonal. So let's figure out what the 2 diagonals are. When I look at my first, I'm just going to pick one randomly, and I'm going to go, all right, let's just look at this one. And figure out, well, how long is it on that one diagonal? Okay, so just from here to here. If the whole design all the way across is 20, and I can see I've got 1, 2 that are set tail to tail, right? I can figure out that each side, if all the way across is 20, then each side across must be 10. So one of my diagonals is 10. And then my other diagonal here is 6.5. So when I put this in my calculator, I can do 1/2 of 10 is 5, and then just do 5 times 6.5. Or I can do 10 times 6.5, which is 65, and then just do 1/2 of 65. And then either way, I'm going to get 32.5. And these, I do have my units, it's centimeters squared. That's one kite, but my logo is 3 kites. So really, I'm going to have 3 kites. That's going to be 3 times 32.5 square centimeters. So 3 times 32.5 is 97.5 square centimeters for the total area of that design. Okay. All right, let's look at this last problem. This problem is kind of interesting because this one we're going to have to do a little working backwards, which if you remember you had to do on your rhombus assessment in the last activity that we did when we did rhombi and squares in the last one. Find x in the figure below. It's kind of hard on this one to tell what the x is going to. The x, I'm really trying to find this length right here is what it's wanting me to find. Okay, so that is what x is. It's that little pink length. It's hard to tell on there. That's what it is. Okay, they are telling me that the area of the whole thing, they've already given it to me. The area is 80 meters squared. So I know when I'm looking at the area is 1/2 diagonal 1 times diagonal 2. I already know my area is 80. That's going to equal 1/2 diagonal 1 times diagonal 2. This diagonal is really simple. It is 10, right? 5 and 5, that diagonal is 10. It's this diagonal that is a little harder because I can see this part is 12 and this part is x. So it's 12 plus x. I don't know what that is because I'm trying to find x. I don't know what that is. So what I'm going to do is I'm just going to leave it as d. And I'm going to solve this equation for this diagonal. Okay, I'm going to solve this equation for this diagonal. Because then once I know the diagonal, the whole diagonal, then I know this little pink piece plus 12 will make whatever that d value is. Okay, so let's go ahead and do that. I'm going to do 80 equals 1/2 of 10 is 5 times d. So to figure out what d is, all I have to do is divide both sides by 5. So 80 divided by 5, I believe, is 16. Is 16. So this whole diagonal from here to here is 16. I know this piece here is 12, and I'm trying to figure out the pink piece. So how do I find out what's left for the pink piece? This 12 and the x together makes 16. So if I take 16 and I take away the 12, then that's going to leave me with the value for x of 4. Okay, so this has to be 4, so that I end up with 16 here, 4 and 12. So when I put a 16 here, I get 160, half of 160 is my 80. It works out perfectly. Okay? All right, so I know this video is a little shorter than the others because I had to stop mid-video on the last one for an announcement. But thank you so much for watching, and if you have any questions on anything kites, rhombi, rectangles, parallelograms, quadrilaterals, polygons, make sure you're attending your sync time and you're asking questions during the tutoring. All right, thank you so much for watching.